Today we're going to be working on expressions and the distributive property. So expressions are a set of terms, numbers, variables, and they do not have an equal sign. As soon as we add an equal sign, it becomes an equation. So what we see on either side of the equal sign would be an expression. And we're going to start with working with expressions. Now, terms are anything that's separated by a plus or a minus sign. So when we count the number of terms, we're counting how many items are separated by pluses or minuses. For example, here I have an x plus 5. I have two terms. An x is a term, and the 5 is a term. And so there's one of each. One is actually a variable, and we'll talk about that in a minute with a letter, and the other one's called a constant. Here we have 3x plus 2/7 y minus 5 plus z. And in this case, as you can see, we have 3x, 2/7 y, negative 5, and z. So we have 4 terms in this expression. Now, we have two different types of terms. The first one is a constant. Now, a constant is simply a plain number. There's no letter, no variable. It can be a positive number, a negative number, a decimal, a fraction, but there's a plain number that is not being multiplied or divided by a number. So just a plain old number is a constant. A variable, on the other hand, is a letter such as X or Y or A or C. So it's a plain letter, like you can see the Z or the X up above. However, it can also have a coefficient. A coefficient is a number in front that symbolizes multiplication, or something like 1/3 that would be multiplied by 1 divided by 3. So our coefficient of our top number of X is that invisible 1. Our coefficient of 3x is 3. Our coefficient of 2/7 y is 2/7. So we can have that coefficient, which is a number in front or a fraction or a decimal in front of that variable, in front of that letter. Now, when we're talking about like terms, we're talking about items that have the same letter and the same power, which is an exponent, not the same coefficient, but it has to have the same letter and the same power, but the number in front can be different, and we call these like terms. So here I have an expression, 3x plus 4x squared minus x plus 7 plus 5x minus 2. And we're looking for those items that are like terms. So I'm looking for my first term here, which is 3x. And I'm looking for anything that has an x to the power of 1. And I see that's a negative x. Notice I said negative x, not x. The sign to the left of that is a part of that term. And our third one here is 5x. These three are like terms, 3x, negative x, and 5x, because they all have a variable of plain x. Notice 4x squared is not, because it's an x squared. It has to have the same letter and the same power to the third power to the fifth power squared. And then we have another set of like terms here. We have a positive 7 and a negative 2. These are our constants. Constants are like terms. So part of our job throughout algebra is to combine like terms. So we're going to combine all of our yellow circles together. 3x minus x is 2x, and 2x plus 5x is 7x. And then we go ahead and we see that we don't have any positive 4x squareds, nothing to combine with our 4x's, so that's plain by itself. And then we're going to combine our orange squares. 7 minus 2 is positive 5. Now, our best order here would actually be 4x squared plus 7x plus 5. We'll work on that a little bit later on. But now we have all combined like terms, or CLT, combined like terms. We combine like terms here, and that means that everything that is the same has been combined together. We have added or subtracted their coefficients. So we have simplified the expression. Now, we use this when we find the distributive property. So the distributive property, here's an example of a numerical example. We have 5 times the quantity, which is what you say when you have a set of parentheses, 4 plus 2. And we're going to go through the steps of how to solve this. The very first step is you're going to draw your arrows. We're going to take the number on the outside and multiply it by each item on the inside. So this is like having 5 bags of 4 plus 2. So we're going to do 5 times 4 and 5 times 2. So 5 times 4 plus 5 times 2. 5 times 4 is 20. 5 times 2 is 10. 20 plus 10 is 30. And we know this is possible to work because we can also solve this problem using order of operations. 4 plus 2 is 6. We do our parentheses first, and then we multiply, which is 5 times 6, which is 30. So why don't we do this all the time? The reason I do this all the time is very often we have letters, we have variables inside, so we can't add a variable and a letter together because they're not like terms. We can't combine x plus 7 because they don't both have an x in them. So just to clarify, our step number 2 after we drew our arrows was to multiply the outside number by every single term on the inside. In this case that we're looking at, we're going to start with 2 terms, but it can be many terms on the inside. Remember, a term is something separated by a plus and a minus. And remember your multiplication rules. A positive times a positive is a positive. A negative times a negative is a positive. And if you have one of each, a positive times a negative or a negative times a positive, that answer is going to be a negative. Finally, you're going to combine like terms like we did at the end there. We combined the 20 and the 10 to get 30. So you're going to combine those terms that are exactly the same. So here we have example 2. We have 6 times the quantity x plus 7. We're going to draw our arrows, and we're going to go 6 times x plus 6 times 7. So we're taking that number 6 on the outside, and we're multiplying it by every single term on the inside. Now 6x is already simplified. We can't do anything else, so that stays 6x. 6 times 7 is positive 42. So our answer becomes 6x plus 42. Use your calculator if you need to for your multiplication. Our third example here, we have negative 4 times the quantity 2x minus 3. So once again, we're going to draw our arrows. We're going to take that negative 4 and multiply it by each term on the inside. So we're going to multiply that negative 4 times 2x. Then we're going to multiply that negative 4 times negative 3. That becomes negative 4 times 2x plus negative 4 times negative 3. Negative 4 times 2x is negative 8x, and negative 4 times negative 3 is positive 12. Nothing to combine for like terms here, so our answer is negative 8x plus 12. We can't combine them anymore because we can't combine an x with a constant. So ladies and gentlemen, we're going to do a lot of practice, 3 different buzz maths with the distributive property today.